Hello ladies and gentlemen, and welcome to the fourth episode of MLITH Season 1. If you're new here, then I'm Valuri Pavan Preetham and welcome to the ML Veda. In the last episode, we discussed about simple linear regression and we actually went ahead and implemented it using Python. And to make it beginner friendly, we actually didn't optimize our code that well and we ended up using for loops to iterate through the data to perform operations on it. So in today's video, we're going to discuss a topic known as vectorization that will help us better represent our data and to optimize the code we had in the previous one so that we can get a better and efficient implementation of linear regression. Stick around till the end of this video because this is a really important topic and it's a concept which will be used in every single machine learning problem we are given to represent and perform operations on the data or the parameters. So let's get started. If you haven't watched the previous video, then you can do so by clicking over here or clicking on the link in the description. It's not necessary to watch the previous video to follow along with this particular video. But if you really do want to check linear regression out, then the starting point is actually in the previous video. So this is the code we have written in the previous video. There are many places which can be improved obviously, but as I told, to make it bigger and friendly, we actually kind of simplified the whole process. Right now in today's video, I want to talk about this particular line, the for loop, right? There's no need for the for loop in this particular case, right? So what we essentially did was iterate through every single element in the x and y to perform some operation one by one. Doing it one by one actually increases the time required to compute the computation and delays our model training, right? So what we're going to do, right, is instead of writing xi multiplied by yi minus y mean into xi, we just simply want to write x multiplied by y minus y mean multiplied by x, where x is just an array of all the data points present in that particular data set, right? And we can do so by simply representing our data in form of matrices. Simply said, matrices are vectors which have data in them organized into rows and columns, okay? And if you still want to dig deep into the concept of matrices, then I have a link added in the description that will help you with matrices. So if you see, we have different operations that can be done on matrices, which is addition, multiplication, subtraction, and matrix product. I'm assuming you guys know all that, right? So what I did before starting this video is actually I went ahead and I implemented my own matrix library. So the main motto of implementing this library is to make sure that you guys understand the underlying principles or underlying functionality of how these linear algebra or matrix or vector libraries actually work, such as Numpy. So towards the end of this video, we'll actually be comparing our library to Numpy's library so that we actually understand what the use of Numpy library is and how important it is for a machine learning engineer. So right now I have a matrix class over here. So I'm just using some magic methods to return our data in a well-formatted way. That's all. And I have this array function which is a static method. It takes in some 2D list or a 1D list and it converts it to a type of matrix object. And it will extract the row and column count of that particular list and store it in the row and column count of our matrix object. Then we have a shape function which will return the dimension of that particular matrix. And we have a function known as fill value which will basically fill the matrix with the same specified value. And I actually implemented this just for the functions ones and zeros, so that I don't have to write a list comprehension every time I want to fill that particular matrix with the same value. Then we have some magic methods add, sub and multiply, and that's basically just to add, subtract and multiply two matrices of the same dimensions. And finally we have the dot function which is nothing but the matrix product. As you can see, I haven't used list comprehension for the matrix product. And the only reason being I want to compare the native for loop algorithm for matrix product with the Numpy's dot function, and I just want to compare the performance, and that's the only reason I've implemented using for loops. So it's pretty basic stuff over here, and if you actually aren't familiar with matrix multiplication, then I have a quick demo for you. So we have two matrices over here, and for matrix multiplication to happen, we need to ensure that the number of columns in the first matrix equal to the number of rows in the second matrix. Only then matrix multiplication is possible, and you'll see why, okay? And the final output of matrix multiplication will be another matrix whose dimensions are the number of rows in the first matrix cross the number of columns in the second matrix. Let's say we have two arbitrary matrices over here and I just click on the multiply button. So what it basically does is it takes every single element row wise in the first matrix and multiplies it to the corresponding element in the column matrix of the second matrix and adds everything together to get the first element of the output matrix. And it keeps doing that throughout the rows and the columns of both the matrices to finally get the matrix product. So the final output matrix is a 3 by 2 matrix as expected. And what you visually saw is what I algorithmically implemented in this particular library. So let's actually go ahead and use this matrix library. So I'm just going to quit out of the LARP program we had, and I'm just going to open a Python shell. So I'm in the same directory as my matrix library is in. So let's make a matrix M1, which actually consists of the following elements: 1 to 1, 2, 3, 2, and 3, 4, 3. So what I can do is quickly print the shape of that particular matrix, and that would give me a 3 cross 3. That's correct, because we do have a 3 cross 3 matrix. And I'm just going to go ahead and make another matrix with the following data: 1, 1, 1, 2, 2, 2, and 3, 3, 3. I'm just keeping it simple so that we can also perform the calculations manually. And m2.shape will give me that, and m1 and m2, just printing them gives me a beautiful representation of the matrices. Now if I do m1 plus m2, that would give me a sum of both the matrices, and m1 minus m2 would give me a difference of the second matrix from the first matrix, and m1 multiplied by m2 would give me a product of matrix, as in element wise product. Now if I want to go ahead and do the matrix product, I would have to use matrix dot dot m1 comma m2, and that gives me the matrix product. Awesome. So it seems like everything is working right now, and what I want to go ahead and do is that compare this particular library with Numpy. So Numpy is a Python library, so it's awesome for any math operations you want to perform, especially when it comes to matrices and vectors type of operations. It's used by all sorts of Python programmers. Maybe you're a data scientist or a machine learning engineer, deep learning engineer, doesn't matter what you are. Every single person who is in the area of Python uses Numpy for sure, at least once in their life. So I'm just going to import Numpy as np over here, and we're going to compare the performance of our library to Numpy. So the same thing, it's np.array numpy2. Actually, I just took it so that you guys can relate to Numpy easily. And let's say we have the same matrix: 1 to 1, sorry, 1 to, only if I could type, 1 to 1, 2, 3, 2, and we have 3, 4, 3, I guess. Yeah, 3, 4, 3. And we have y equal to np.array of 1, 1, 1, 2, 2, 2, and 3, 3, 3. So let's directly jump to matrix product, because I guess that's the only thing we are here to compare. That gives us the same answer, but let's see the difference now. So this Python interactive shell has a cool feature called time it. So what this basically does is, it basically computes how long does your processor take to execute that particular operation. So first I'm going to go ahead and use the matrix product made by me in my matrix library. So matrix dot of m1 comma m2. So let's just wait for a while, and then that will spit out time in micro or nanoseconds depending on the speed of my processor. And is i5, so hopefully, yeah, that's quick enough, I guess. So we got around 12.6 microseconds, and that's pretty good actually. Even though we use 3 for loops and stuff, 3 for loops is actually nothing. But then if you think of it as an algorithmic point of view, then it's actually a lot. Now let's go ahead and do it for Numpy. Numpy dot x comma y. I'm sorry, I forgot the time it part, and I'm just gonna time it. And it should give the answer anytime now. Come on. Should be there. Yeah, it's right there. So it's 1.2 microsecond, right? You see the difference in speed. That's 12.6 microsecond and 1.2 microsecond. So you may argue that it's not big of a difference, it's just 11 microseconds. Yeah, 11 microseconds is not that big of a difference, but then here it was just a 3 cross 3 array, right? And sometimes you have data sets that have 1 million records or 2 million records. And when your model encounters such data sets, then the time taken to actually perform this computation increases drastically. So it's always good to have an optimized implementation of whatever you're doing. So instead of going ahead and using the library which I made, from this episode onwards, we'll be sticking to NumPy. So if you're not familiar with NumPy, I highly recommend you to learn how to use NumPy by reading the documentation or watching any other video on YouTube or any other source you are familiar with. Also, the library which we wrote is only compatible with 1D and 2D matrices, but NumPy is actually comfortable working with matrices of any dimensions. So what I'm going to do right now at this point is go to our lr.py and actually modify this code so that we actually don't use those for loops anymore. So first thing I'm going to do is go ahead and import numpy as np. And then we are going to take this and convert to a numpy array. We did that, awesome, and convert that into a numpy array, but instead of using list comprehension, we can actually go ahead and do 2 multiplied by x minus 1. See, that's how simple NumPy makes it for us, and we just complicate our lives and use list comprehensions and use for loops. I'm sorry, that's actually me. And we actually don't need this num equal to 0 and denominator equal to 0, and we don't need this y mean equal to the computed mean of y and x mean part. We don't need this for loop anymore. We don't need these two anymore. It's pretty simple over here. What I'm going to do is directly write m equals to sum of x multiplied by y minus np.mean of x multiplied by y divided by sum of x multiplied by x minus np.mean of x multiplied by x. Believe it or not, that actually will give us the value of m. And to compute the value of c, we just have to use np.mean of x and np.mean of y. Let's go ahead and execute that. lr.py. It should take a while because it has to actually go ahead and import NumPy. I'm sorry. Oh, we used lowercase. And is it lowercase anywhere else? Yes, I don't know. Oh, you know what? Actually, I'll just go use lowercase because I just have to change this particular line. It's good to be lazy. I guess that's it. That should work. There we have it. We have a slope of 2 and intercept of -1, and we also have the plot. So today's video was all about how to use vectorization to get a better implementation of the code we already have instead of using for loops and iterating through the dataset and going through every single point and performing some operation on them. Right now, this may not seem like a drastic improvement to you because the speed of execution for both the code snippets we had earlier and now it's almost the same, right? You might not see a big difference right now, but you can see that it's almost a reduction of 4 to 5 lines in code. But if you actually scale up to larger data sets, then you can see a significant difference in the execution speed and also the implementation difficulty, because when you actually use real life data sets and data sets which are really huge, it's actually not that easy to iterate through every single element and perform operations on them. So why not just go the easier and the most efficient way, which is using NumPy. So throughout this series, we'll be using NumPy for the same reasons which I mentioned before, or any other libraries which might make our life easier. And if you already aren't familiar with using NumPy, then I highly suggest you to learn it, probably from the documentation or any other source which you are familiar with. So we still have 2 other problems to tackle. One is multivariate datasets, which is actually 3 missing values. Yeah, so we still have 3 problems to tackle. One is multivariate data, as in we have more than one independent variable. The second one is using a real life dataset instead of something that's really straightforward what we have right now. So in the next episode, we'll have to pick a good enough dataset that will help us understand linear regression and implement it better, so that we actually get the feeling that we have implemented a true machine learning algorithm. Because right now, yeah, this is also a linear regression model, but then it's just a dummy data set, right? So let's challenge ourselves and take up a real life data set and try to solve it. And the third one is missing data. This is one of the most irritating parts. It's so irritating. You have to clean your data every time. There's a huge process to just decide whether to keep the missing data or remove it. right? And you use a technique called imputation, where you try to fill the missing data using the remaining data you have in the dataset. So this is a huge headache we have. So we'll be tackling these 3 challenges in the next video, where we'll start multiple linear regression and we'll have an improvement over this model. And I guess it'll be the right time to go ahead and actually start building it as a library. Instead of writing it as a script, what we did now, probably from the next video, we can actually go ahead and build it as a library so that we can use it for any kind of machine learning task we are given in the future videos. So that's all for today. And if you actually like the video, then go ahead and smash the like button and subscribe to the ML Veda if you already haven't. So see you guys in the next episode of MLITH Season 1. Keep learning.